Everyone and welcome back to VectorX Academy. This is Satyatej and in today's class we will be learning on permutations and combinations. So let's get right into it. Start with basic principles. First one will be multiplication principle. Let us assume there are two events A and B, and event A can occur in m ways and event B can occur in n ways. Then the number of ways in which event A and B occurs in succession will be m into n. This is multiplication principle. Now let us take an example. If you want to go from city A to city C via city B, when you can go from city A to city B in two ways and city B to city C in three ways, then the number of ways in which you can go from city A to city C via B will be 2 into 3, 6 ways. And if you want to go from city A to city C via B and again return in city up to city A via B will be 2 into 3 into 3 into 2, that is 36 ways. Now addition principle. Let us assume event A and event B. Take two events A and B where event A can occur in m ways and event B can occur in n ways. Then the number of ways in which either A or B occurs will be m plus n. Example, same. From city A you want to go to city B or city C. To city B there are two ways and to city C there are four ways. Then the number of ways in which you can go from city A to city B or C will be 2 plus 4, 6 ways. We will start with permutations. What is a permutation? A permutation can be said as number of ways in which you can arrange n different objects taking some or all. Number of ways in which you can arrange n different objects. All or some, taking all or some, is known as permutation, and we denote it as permutation of r n different objects, permutation of r different objects taken from n different objects will be denoted as NPR. Number of ways in which you can arrange r different objects from n different objects, we denote it as NPR. Now let's try to find out the expansion of NPR. Let us take, there are n objects A1 up to AN. There are n boxes. Let's take as box 1, 2, 3 up to R. Then the number of ways in which you can fill R boxes from n objects. Like will be, in first box you can take any of the n objects, so n ways. In second box, if one of them is chosen, let us take a3 is chosen, then the number of objects remaining are n minus 1. So you can choose n minus 1 objects. You can choose from n minus 1 objects. Now for third one, n minus 2 up to n minus r minus 1. For rth object you will get, you can choose from these many objects. So the number of ways in which you can arrange the numbers a1 to an will be n into n minus 1 into hence on up to n minus r minus 1. Now for this, let us multiply r into n minus r into n minus r plus n minus r minus 1 into hence on up to 2 into 1. Then we will get npr as n into n minus 1 into up to 2 into 1 by n minus r into n minus r minus 1 into hence on up to 2 into 1. Now factorial. We denote n into n minus 1 into n minus 2 into hence on into 2 into 1 as n factorial. Then npr will be n factorial by n minus r factorial. Therefore, the formula for permutation of r objects from n different objects will be n factorial by n minus r factorial. Let's do one question from this. Now let us do this question. How many 4-digit numbers can be made using digits 1, 2, 3, 7, 8, 9 when repetition of digits is allowed, repetition of digits is not allowed? We will do the repetition of digits is allowed afterwards. First we will do the repetition of digits not allowed. Second one. They are saying that we want to make 4-digit number using 6 digits. Therefore, number of ways will be 6p4. Arranging 4 numbers from 6 objects. 6 different numbers will, that is 6 factorial by 6 minus 4 factorial. 6 factorial by 2 factorial. That equals to 6 into 5 into 4 into 3. 360. Now we will learn some concept. Permutation with repetition. Let us take the above first part as the example. How many 4-digit numbers can be made by using digits 1, 2, 3, 7, 8, 9 when repetition of digits are allowed? Now we want a 4-digit number using digits 1, 2, 3, 7, 8, 9. When repetition of digits are allowed, then things will get different. If we choose 1 from the above 6, let's say 3, then the number of ways for this will be also same. Since repetition of digits are allowed, you can choose another one again. So the number of ways for one's digit will be 6. For number of ways for which you can choose tens digit will be also 6, and for hundreds digit is also 6, and for thousands also 6. Therefore number of ways will be 6 into 6 into 6 into 6, 6 power 4. Similarly, if we want to arrange a1, a2, hence on n different objects in r places, when repetition is allowed, then the number of ways will be, for the first place there will be n chances, second also n, up to, for all r places there are n chances. So the number of ways will be n power r when repetition is allowed. Therefore, let us summarize. Permutation of r different objects from n different objects. First one, when repetition, without repetition will be npr, and for this with repetition it will be n power r. Hashtag means number of ways. Now the next topic, rank of a word. They will ask rank of a word. For example, they will ask rank of a cat, word cat. Now, if we permit if we arrange all the alphabets in the cat, we will get CAT, CTA, TAC, TCA, ACT, ATC. Now we want to find the, if we arrange them in alphabetical order, means in dictionary order, we will get first one as ACT, second will be ATC, third will be CAT, fourth will be CTA, fifth will be TAC, sixth will be TCA. Then the rank of cat is third. First rank of act is 1, rank of ATC is 2, and rank of cat is 3. Now, as it is a 3-letter object, we can easily find like this. If it is a big letter object like vector, VECTOR, we want to find the rank of word vector. How will we find it? Now we want to find the rank of vector, VECTOR. First we will arrange the alphabets in alphabetical order. First we will come C, second will be E, third will be O, fourth will be T, then V, no, O, then R, then T, then V. Now we want the rank of vector. If you want to find the rank of vector, if we just find out the number of words which are above the rank vector, we will get the rank of vector. For this, it is a 6-letter object. We will do like this. The first is C. Number of words which starting from C in the with letters CEORTV will be, here number of words can be 1 2 3 4 5. Here will be 4 3 2 and 1, 5 factorial. Then after that the words will start with letter E, again 5 factorial. After E, the words will start with O, again 5 factorial. After O, words will start with R, again 5 factorial ways, then T, again 5 factorial ways. Now V, we got the first letter. The next one is E. Again we will do alphabetical order, removing V. First one will be C. C. Then the number of words can be formed are, here there will be four words, 3, 2, 1, 4 factorial. Then the next one is E. We got the letter. We want what we want. We got it. Now we will go into next one. Again E is cancelled out. Next we want C. As C is the first letter, it starts with C. So there are no words. Then after C, we want T. But it will start with letter O. Number of words will be 1, 2 and 1. 2 factorial. Next VEC will be R, again 2 factorial, then VECT, then we will get O and then R. They are in order, so 0 words. Therefore, number of words above vector will be 5 factorial into 4 plus 4 factorial plus 2 factorial into 2. These are the number of words which are above the word vector. So if we want to find the word vector, rank of vector, we should add 1. Since see, the number of words above cat are 2, but the rank is 3. So we should add 1. We will get the rank of vector as 5 factorial is 5 4s are 20, 20 into 6, 120. 120 into 4, 480 plus 4 factorial 24 plus 2 factorial, 2 into 2, 4 plus 1. That is 480 plus 29, 509. Therefore, the rank of word vector is 509. This is one type of problems they can ask. Now, the another type will be permutation of alike objects. For example, let us take, there are A similar objects. We will do one question on this. Let's take an example. We want to arrange A, A, C and D in 4 ways. In 4, we want to arrange these 4 letters. How can we arrange? Here, 2 of the objects are similar. So, number of ways will be different, since see, A, C, D and A, again A, C, D. We will count them as 2. So, for the permutation of like these objects, we will get the permutation number of ways as 4 factorial by 2 factorial. That is total number of ways by number of alike objects factorial. Permutation of n different objects. number of permutations of n different objects where k of them are of one kind and q of them are alike another kind will be number of ways will be n factorial by k factorial into q factorial. Like for example, there are n different objects, n objects, in that k of them are same and q of them are same but with different number. Then the number of ways will be n factorial by k factorial into q factorial. Now we will do for an example and do some problems. Example, find the rank of the word daddy. Here, three of them are same. So let us first arrange them in order A, D, D, D and Y. Now, number of ways in which number of words will come taking A as first word will be 4 factorial by 3 factorial. Since three of them are alike, total are 4, 4 factorial by 3 factorial. The next one will be D, so we want that only. Well, next one will be A, again D, again D and again Y. Direct. Here it is 4 and this is plus 1 we will add. Therefore, the rank of daddy will be 5. Now let us do some problems on permutations. The first one, find the total number of 9-digit numbers of different digits. Now first we will write all the digits 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Here we want a 9-digit number 1, 2, 3, 4, 5, 6, 7, 8, 9. Now for the first place number of digits it can come here are 9. Since 0 can't come, we have to choose one digit from these 9 numbers. So let us assume 2 is taken. Here it will be like again 9. Since here 0 can come. Here it is 8 and so on up to 1 we will come. That is number of total numbers will be 9 into 9 factorial. That is that's it. Therefore, the answer is 9 into 9 factorial. Now we will do into second question. In a hotel, 4 rooms are available. 6 persons are to be accommodated in these 4 rooms in such a way that each of these rooms contains at least 1 person and at most 2 persons. Then the number of possible ways this can be done is. Now, they said that there are 6 persons and so and there should be at least 1 person in each room. So let us assign those 1 person in 4 rooms like 6p4. We are taking 6 persons and arranging them in 4 rooms into and the another 2 persons will go into p1, p2, p3 and p4. Remaining are p5 and p6. He can go into one of the 4 rooms and the other one can go into one of the 3 where p5 is not there. Since the maximum amount of people are 2, so p6 can go into 3 rooms. 3. Therefore, 6 into the number of ways will be 6 factorial by 2 factorial into 4 into 3. 360 into 12. That is 0, 36, 12, 6, 6, 12, 3, 3, 3, 2, 0. This completes our today's class, and we will see you in next class.